Welcome to our session. Let's get started. We will talk about BlueJeans' explosive growth journey on AWS during the pandemic. A little bit introduction. My name is Daniel Lee. I'm a solutions architect at AWS. I'm joined by Behrooz Nasri, VP of Operations and Security at BlueJeans by Verizon. BlueJeans is a global leader in cloud video conferencing. Let's look at our agenda. We will firstly talk about the challenges imposed by the pandemic. Then we will walk through the architecture and how it evolved. Then we will share how and what was implemented on AWS and some of the lessons learned. We will close the session by sharing some key takeaways. So let's go to the challenges. In 2020, the pandemic caused a lot of challenges and changes. Many companies, schools, and other organizations had to reduce face-to-face interactions and shift to online video conferencing. As a result, online video conferencing providers such as BlueJeans faced a lot of scaling challenges. In the first few weeks of March, BlueJeans saw 300% growth in video conferencing usage. BlueJeans has been running their infrastructure primarily on-prem. Their servers reached capacity quickly, and they were not able to add capacity fast enough because typically server procurement would take 9 weeks or longer. So what should they do? BlueJeans became an AWS customer a few years ago. They had been using AWS primarily for overflow capacity and disaster recovery. With this new challenge, they decided to shift their cloud strategy. They would switch to AWS as the primary infrastructure and use on-prem as secondary. They worked with AWS teams to triple the meeting capacity in 3 weeks. They added capacity in the United States, Europe, and Asia Pacific, all on AWS. And they migrated the on-prem MySQL database to Amazon Aurora. Amazon Aurora is a MySQL and PostgreSQL compatible relational database built for the cloud. It offers the scalability, performance, and availability with much lower cost than the commercial relational databases, but with the open source flexibility. BlueJeans also modernized their applications to use microservices and containers. They deployed the containers to Amazon EKS, which is our Elastic Kubernetes service. I will hand over to Behrooz. He will share some insights about the challenges, the architecture, how they did it in implementation, the lesson learned, and some key takeaways. Behrooz, over to you.
Thank you, Danielle, for the introduction. I just want to start by giving a little bit of an overview of BlueJeans at a glance and our product lines. So BlueJeans is one of the leaders and innovators of cloud and video meeting and events. We have 27,000 enterprise customers, and we were acquired and we're part of Verizon this year in May. Our product line is in 4 major categories. One is our flagship meetings, that it is used for video conferencing and collaboration effectively for video, audio, and web conferencing. We also have our events product, which is designed for hosting an interactive town hall and very large global audiences. Our room systems allows interoperability amongst various conferencing rooms and conference systems so they can collaborate effectively. And we also have a product specifically designed to help enable access and interoperability between Microsoft Teams and any kind of room systems they have. This is just a fairly broad overview of our platform. On the client layer side, we have native applications for Windows, Microsoft Linux, as well as iOS and Androids. We also provide WebRTC and web, so you can connect through web browser directly. And you can, there's a separate client for our events product that if it needs to be used. And we also have clients that get installed in various rooms that get used. And as in our core products are the ones that I mentioned earlier: the meetings product, the events product, rooms, and Teams Gateway. And then since BlueJeans was designed specifically for enterprise usage, we have another layer of sort of shared management layer for enterprise admins, IT administrators. Our command center gives insight into usage patterns to the enterprises. We also provide monitoring and logging that our customers can use to effectively design and understand the usage pattern of their applications. Our meetings product, as Daniel mentioned, was designed originally on data centers, and for the last 2-3 years we've been working on expanding it and using it in AWS. Our events system was built from ground up 100% on AWS and has always been there for us. So those are the two core products, and one was again, we're trying to move to AWS, and the other one was we just started right off the bat on AWS. So this is we're specifically going to talk about our meetings, our video conferencing, and what happened at the beginning of this, the first 2-3 months of the year for us. As you can see, right around early, late February, early March, we start seeing indications starting in China about people needing more staying home or working from home and not going to offices. And then within a matter of weeks, our usage went up 3.5 times. And as you can see from this, the bulk of the usage increase was desktop because people were going home and they were on their computers. So it was not, mobile went up a little bit, but as you can see, room systems start going down because people are not in the offices, and the PSTN using basically phone to call in, and mobile stayed comparatively, it went up a little bit, but it stayed fairly flat. But the desktop usage which is our people were using it in the home, was the one that dramatically increased for us. So this is I'm going to talk about how we try to manage this and how we try to address this huge demand from our customers to make sure that they can be productive. So as I mentioned, in February we started seeing some of our large global enterprises who had a fairly large mainland China presence starting to send their employees to work from home. They reached out to us to see if we can manage the capacity or be able to support them. And this was not only a capacity issue of providing video, but also, especially for mainland China, it was getting clean bandwidth and connectivity out of China, which was even more critical for us. So at the initial phases, what we were focusing on or what we were working on was the usage and providing additional capacity of bandwidth going into China. And we increased that by 5-folds in those 2 weeks in late February and then from there. The actual capacity of meetings, we had enough at the time, so we were not really seeing a lot of other usage. And then we started seeing other places, Europe, especially in Italy and other places, started coming in and started to show usage. And that was especially we had distance learning and large sort of universities in Europe who tried to send their students home, and they wanted us to be able to provide additional support to them. And again, this was early March. And then by by literally by early March 7th, March 8th, we started getting calls from many of our key large enterprises in United States that hey, this is Friday. This was literally on a Friday, saying that we're basically going to announce and send everybody home. And these are companies of each one 40, 50, 60,000 employees, some of the larger enterprises. And they asked us, we're sending everybody home. Monday morning, everybody's going to be on a call from that. Can you guys support and can you guys be able to provide support for us? And we absolutely wanted to do that. And this is something that we very confidently told him, absolutely, you can send your customers home and we will be able to provide what you need for that. So I want to talk about some of the things we did and how this was achieved. So first of all, in March, our deployment model, as I mentioned, we have a media layer which does the actual video conferencing and is regional. So a logical partition is designed to have media capacity in global regions across in various regions across the globe. And so after you join a meeting, the actual transaction, the actual video and the traffic is handled within the various regions within your partition that you're in, and you're trying to do that. So this was our old application was basically running on EC2. We already were doing overflow, so we were having up these partitions running in our data centers, and during the business hours, we were bringing up additional capacity in AWS, and we were and then after the 5 o'clock local time, we were bringing it back down. However, we just simply did not have enough capacity. So what we wanted to do is to build the entire media layer instead of as an overflow, but as an actual complete environment in various AWS regions. So bulk of our growth was to build out media layers and media POPs and additional capacity within the globe. So we not only increased and built out in the regions we existed, but we also we went to other regions. We were not in Ohio. We started using Ohio, US East 2. We were not in Singapore. We started using Singapore. We started bringing Mumbai up. So we had and several other locations that we were not present at the time. We actually increased and started bringing regions up on those. The other components of our is the sort of the logic layer, the application layer, and that one is we were already in a process of migrating all of that to AWS out of our data centers, but so some were already in Amazon, and the other ones we were in process of migrating. When the surge and when the capacity need occurred, we decided to pause the migration and just build new application layers directly inside of Amazon, and that one, we were already working to containerize and put it in Amazon EKS. So all the stuff that we built on the application layer was done with EKS, and it was done directly in US West 2 as the primary and US East 1 as our secondary for that. We also have a sort of an edge layer that when the initial sort of signal or join meeting comes in, it decides which partition or which of the application layer it has to connect to, and that was also in our data center, and we had planned to systematically move it over, but we had to basically, one of the key components of that was our MySQL database, which is the holds most of the metadata, most of the credentials, meeting information on it. That one was actually hitting capacity, so we had to accelerate the move of the database to Aurora in March, and then we still had planned to move the rest of it over to get there. So this was our. We were already in a transition to starting using more and more AWS. However, this sort of really accelerated build out. So it paused the migration, but accelerated the build out for us. And this was done in a matter of like 2-3 weeks for us. So as we speak now, we have already, if you notice, moved our media layers that are running in Amazon to EKS also. So we've already containerized our media layer, which was not at March. And currently we moved all of our application layer to Amazon, so we no longer use our data centers for that. And we've already moved our edge layer to Amazon also, and we're using Aurora as our active database, and then even the replications are all Amazon Aurora replicators do that. So this was a journey for us who we were planning on doing, but it was it was accelerated quite a bit to add capacity first in March, but then we continued our architectural migration with AWS also. Given all of this, we basically tripled the entire meeting capacity for us, and that was done in a matter of 3 weeks. We were building these partitions on a daily basis, and we were adding sort of a partition a day to add capacity, and we continuously do that for about 3 weeks. By mid-March, end of March, we start seeing sort of peak usage for our customers, enterprise customers that we had. And after that, we still added capacity for another 2.5 months, but those were for new enterprises that were trying to use our services as the need arises for them. The other big things we did is, which was actually a lot easier for us because all of it was already baked into, it was actually built out in AWS to begin with, was our events product, and we increased its capacity. So not only we can have more simultaneous events and town halls, but we can have the capacity of each individual event move up to 50,000 attendees. And we were able to help several of our large enterprise customers had their annual meetings, such as reInvent, but their versions of it, and they wanted to also start moving that online. So we were able to partner with them and be able to support them in what they required to be doing from there. And as I mentioned, we also in the 2-3 weeks started moving to at least 3 new AWS regions that we were not in before, so we were able to do that. And then what we ended up doing is we still wanted to use our scheduling feature to be able to bring capacity up during the peak business hours. for the various regions, and then shut them back down for night and on weekends. And since this was a huge capacity increase for us, and this was in March, we wanted to, in the middle of all this, we also tried to see if we can use spot instances to reduce overall cost as much as possible while we're doing these things. So not only we were increasing capacity, we were moving to EKS and containerize. We also tried to use spot instances to some extent. So this is although we could use various system of basically automatically using automatic capacity increases, the issue we had is video conferencing and usage is first of all is predictable. Typically, it's 8 o'clock, 9 o'clock in the morning till about 5 o'clock in the afternoon, you get a large usage and then it comes back down. But more importantly, you end up having large peaks at top of the hour and bottom of the hour. And these peaks literally happen in a matter of 15, 20 seconds. Using auto scaling group or any other sort of load detection of increasing capacity, it's just simply not going to be fast enough to handle that top of the hour usage for us. So because we knew what it is, we basically had our own schedule of capacity ramp up and ramp down built that we basically put it in a DynamoDB, and from there a Lambda function will run every 5 minutes, and it will actually start bringing up the instances that we know. These were already provisioned instances, but they were just stopped. So we will actually start these back up, and it takes them a few minutes to join, but we do this ahead of time. So by the time the top of the hour hits, the capacity is available and people can get to use it. At the same time, while these EC2s we were bringing up, we tried to get a mix of spot instances versus on demand on some of these things. So what we ended up doing is using the Amazon CloudWatch and their sort of signals that if a spot instance was going to get terminated, you get your 2-minute notice. So we were watching for that. If a notice would come for that, we would send a signal to that particular machine, the EC2 instance, to do a graceful drain for us. So within the 2 minutes. So when the instance goes away, it reduces the impact to the customers or the meetings was happening to be on that instance and have gone to some other instance. And we're also recording the impact that event took place on Slack, so we can see how much of that was happening for us. So this way we were able to. This was before we moved to EKS. Now that we are in our current model, we still bring up the pods and reduce them, but we're using EKS and Kubernetes scheduling systems to be able to do that and not necessarily do it from external systems like this. The other major accomplishment that was for people who've tried to do this, then they know it's this could be tricky, and this could be something that it was a huge accomplishment for us to get done in such a short period of time, was our database, our hardware-based database, MySQL, that we had in our data center was absolutely reaching its maximum connection limit, and it was nothing else we can do with it. And also we had especially our roster updates, so we know who's in whose meeting. Those are heavy write, and all of that is parallelized, but since we want to make sure all of our regions are, and all the locations and all the partitions are aware of it, we had to basically use that to replicate to the read-only. But that was not really as fast as it should be. So the replication lag was happening. So sometime if you join a meeting, you will not see who else was in there at the same time. But the bigger problem was we were reaching max connection limit. So we had been working on trying to move to Aurora, and even the default connection limit of 7,000 was enough for us, but we could actually have increased that from to 16K if required. We didn't. We moved it to about a 9 or 10,000. That was more than sufficient to handle the load. And the huge benefit was that the Aurora replication to other Aurora was the lag was it was almost no lag. So that made it a much better user experience when they were joining the systems. So, and this was, we actually did this, we had tested it of what we decided that we have to do this while we were in the middle of all of the surge and all of the capacity increase. So over a weekend, we tested it, but over a weekend, we actually completely switched and made Aurora the right database, and we made the MySQL. We still had a few in the data center; those be read-only replications off of that. Couple of lessons learned from us is first of all, spot instance. I thought this was a great exercise for us. We are using spots right now in a little bit different fashion, but there are some key takeaway that our original application was never really built for cloud usage, and it was built for a data center, and we later on moving it to some of these. The application must really be able to do a very graceful termination. Otherwise, there will be impact, and this is doubly so for our media layer, which is really it's a stateful application. You have active meetings running on it, so you will actually notice that there are issues, and if you're switching to somebody else, you will notice that little pause or a lag. Whereas a web-based application, which is stateless, if you just go from one instance to another instance, it's not really noticeable. And the other one is that if you really want to use spots, you have to make sure that you're flexible. You have a lot of flexibility in different instance types, because the one you need right away might not be available. So you just have to, the more choice you give, the better chance you have to be able to have it available. And then also you just have to make sure you balance between how much on demand and how much spot you want to use. And this way, by that ratio, you make sure that you always have at least a minimum capacity available. And then just in case one particular region spots were not available, which certainly this year, due to the huge usage and demand across the globe, there are times that the capacity was just simply not there, especially for the type of instances we required. Since then, we're actually moving our application to be much more agile, that it can use different types of instances instead of being tied to a specific type of instance. And our application layer, which is also more stateless, those are already starting to use spot instances back in our systems, and we're also started using spots wherever we can as we're increasing the portfolio of instances that can be used. And the other things that I want to mention is for the database migration. This is the way we try to do it. We started first of all using Procona at the time. We were using extra backup for that. So we started doing dumping and loading. And as that was happening, we started bringing Aurora up to, so it was getting replicated directly from our systems. And then once we were ready to do that, we basically, through DNS switches, we actually just converted which is the main database and which one is not. And we were able to quickly, very seamlessly move the applications over. Although we shut a lot of the applications down to just bring them up, but even that was not necessary. Majority of our application were able to just quickly reconnect and go from there, and it was quite smooth. And most people did not even notice we were doing this on the back end. So this was another great feat for us to be able to do this entire migration in less than a week. So as I mentioned, we had already started working on moving to containerized and more modernized systems that are designed for the cloud and for public clouds. But when the surge occurred for us in March, we basically paused that to just in lieu of just adding capacity. But the minute we sort of peaked, we quickly went back and continued with our application. And right now we're basically most of our deployments, our meetings application is running on Amazon EKS, both the application and media layer that has already been migrating over to that. And the edge layer component, the very last layer, was the one that we actually did in the last few weeks. So even that is basically completed over. And then in summary, again, just want to say that this is what we end up getting. We connected, 5 times, more users together during the peak of the pandemic than before that. Our enterprise customer base went up from 13,000 to about 27,000. Just our bookings and everything else was sort of doubled year over year. And the other one that I think this is going to be it's going to be a lasting impact. And I'm sure that the issues of the pandemic will get resolved. We will have solutions for that. But people will notice that they can be effective at working and with less travel and be able to do that. And we save a huge metric ton of carbon dioxide by just not traveling all over the place from this. And I think this is going to be building to the culture of future workplaces and be able to connect using the cloud and using video to be able to communicate with their colleagues. And I'm just going to finish. This is the quote from our own CTO. The trust that the customers put in BlueJeans motivate us to leave no stones unturned. And throughout this whole thing, AWS was a partner for us, and it allowed us to scale and meet the need of this very unique situation for us. This was an amazing partnership for us that we would not have been successful without AWS. Thank you very much, and appreciate it. And there is a survey at the end of this, so if you get the chance, please complete the survey and send it in. Thank you.